Good morning, ladies and gentlemen. Welcome to the 2G and 2H answer marathon. Clearly, I'm not expecting you to watch this entire video, but as you get stuck through 2G and 2H, skip forward to this section of the video. I'll try and have them clearly labeled so you can skip easily to where you get stuck on the question. I'm not going to do every single one of them, but I'll do the second half of both problem sets because they tend to be where the more difficult ones land. So we're starting with 2G, question 4. And very nicely, they give us a formula. The number of diagonals on an n-sided polygon is given by the formula d equals n on 2 n take 3. Okay? A polygon has 90 diagonals. How many sides does it have? Alright, 90 diagonals is telling us to substitute into the formula. So 90 equals n on 2 n take 3. Then we solve. Probably a couple of ways to solve, but I would start off by multiplying by 2. It's a common factor on this side, so we only need to do it once. The 2 goes up there. So 180 equals, and then I'm going to expand the brackets out, n squared take 3n. Then we're aiming in most circumstances to get 0 by itself. So 0 equals n squared take 3n take 180. Now, a couple of ways to solve from here. Polynomial solver, graphics calculator, quadratic formula, but because we're asked for how many sides it has, we're expecting integer solution. Integer solutions often factorize. So in this case, you can probably get away with sum and product. You're looking for something that adds to minus 3 and multiplies to negative 180. And if you're not entirely sure, I would take negative 180 aside and break it up into its factors. There's clearly 2 and 90, with one of them being negative. There is 4 and 45. Again, we want a difference of 3, so they're not great. You can divide one side by 3 and multiply the other side by 3 in any of these factors. So for example, clearly multiplying this one by 3 would give me 6, dividing this one by 3 would give me 36 and 30. However, I think we've just landed on the one we want, this one, 12 and 15, and we want it to be negative 3, so we're thinking negative 15. This then factorizes into 0 bracket n take 15, n plus 12. Our two solutions are n equals 15 and negative 12, but because we're asked for how many sides something has, you can't have negative 12 sides, so we're going to discount that, and our answer is n equals 15. Alright, question 4. The length of a rectangle is 4 centimeters longer than its width. The rectangle has an area of 26 centimeters. Find the width. Alright, anytime you're given a description of something and not a picture, draw a picture. Alright, well, let's make the width be x. Oh, second hint, when it says find the width, as soon as it says find anything, let that anything be x. X plus 4. And then you're told x plus 4 equals 26. X squared plus 4x minus 26 equals 0. So a couple of steps at the same time, but we've gone into our sort of standard form. I don't think that's going to factorize, and we can reasonably have a decimal answer because you have a decimal length of side. So you can go menu, polynomial, solver. Oh, my head's in the way. Give me my calculator back. Execute 2, degree 2. What was it? 1, 4, neg 26. All right. Side can't be negative, but 3.4722. Centimeters, because the original is in centimeters. Now note, if it asks for the exact width, that's not exact. That will be a decimal approximation of a square root. To get the square root, we would need to use the quadratic formula. But since it doesn't ask for exact, that's fine. Alright, still in 2G. Question 6. A rectangular box has a square base, and its height is 1 centimeters longer than its base length. The total surface area of the box is 240 centimeters. Suppose that the sides of the base are x centimeters long. Show the total surface area is given by a equals 6x squared plus 4x. Alright, each of these heights is x plus 1. Alright, now we are assuming that it has a top. A rectangular box has a square base, so we're assuming it has a bottom and a top. So the bottom and the top have areas of x squared and x squared. So the surface area is really 2 lots of x squared, that's the top and the bottom, plus 4 lots of, well, this is going to be x multiplied by x plus 1. All right, so let's see how that goes. Surface area is 2x squared plus 4x squared plus 4x is 6x squared plus 4x, which is where they've shown. So we're going to finish there. If you want to be a real sort of math nerd / dick, you can end with QED. If you Google it, it's Latin, basically saying you've asked me to do something, I've done it. Boom. QED. You don't really earn a QED with something that's 3 lines long. All right, anyway, find the dimensions of the box given that it's 240. All right, so the surface area is given by this expression, and we know that expression is equal to 240. We say 240 is 6x squared plus 4x. Subtract that over. 0 equals 6x squared plus 4x minus 240. And then does it say exact? No, it just says find the dimensions. So we both need the length, width, and height. We need x, then x plus 1. We can throw that into our calculator again. X, what was it? 6, 4, negative 240. 6 and negative 666. Okay, so clearly the negative isn't applicable here because we need a positive length. So we're going x equals 6. X equals 6. Therefore, the width is 6 and the height is 7. All right. Question 7. An open box can hold 80 cubic centimeters. Note volume. It is made from a square piece of tin plate with 3 centimeter squares cut from each of its 4 corners. Find the dimensions of the original tin plate. All right, so it was originally a square, and when it says find the dimensions of the original tin plate, I would let this entire thing here be x. There's probably more than one way to do this, but let's make that entire thing be x, because that's what it asked for. It asked for x, which is the original dimensions. So, really, what we have is this side here being x take 6, and that one being 3. And same again, x take 6, 3, and this one is x take 6 and x take 6. All right, so it's an open box, meaning there's no lid, it's just those colored bits that we see. I would say that is the volume is length times width times height. The volume is 80, and the length of this box is x takes 6. The width of this box is also x takes 6, and its height is 3, because when it folds up, it makes a 3 high box. All right, so if 80 was divisible by 3, I'd divide the 3 out, but it's not, so let's just leave it there. 80 equals, FOIL this out, x squared take 12x plus 36 with a 3 at the front. 80 equals 3x squared minus 36x plus, what's 36 times 3? 108? Feels like a 108. Cool. Then let's take 80 from both sides. 0 equals 3x squared take 36x plus 28. I'll factor 3 out of them all. Quadratic formula or trusty calculator. What was it? 3 neg 36 plus 28. 3 neg 36 plus 28. All right. 2 potential answers. 0.83 and 11.16. Now, if you look back here, 0.83 for x sounds great, but you can't take 3 away from it and still have a positive side. It essentially eliminates that answer. It wouldn't fit in with the question. It doesn't make sense. Which leaves us our second solution, and our second solution does make sense. 11.16. X equals 11.16 centimeters. And that is the original dimensions of the box, 11.16 by 11.16. So that's both the length and the width. All right, that's 2D. Space. So this is now quadratic optimization. And our friend for this entire section is the turning point, or the x-coordinate of the turning point is minus b on 2a. That will get us that x-coordinate of the turning point. Also, we can use the calculator, but without a calculator, we use this. All right, a rectangular plot is enclosed by 200 meters of fencing. Show that. All right, if we have x, I'm just going to call this one L for the purpose of showing it. So that means 2x plus 2L equals 200. X plus L equals 100. Sorry. L equals 100 minus x. So this side here is really 100 minus x. That means the area is length times width is x, bracket 100, take x, which then expands out to 100, 100x, take x squared. All right, shown. The area is maximized as a square. We need to show that it's maximized as a square. All right, well, it is maximized when x equals minus b on 2a. In this case here, that x value would be negative b is plus 100 on 2, which is 50. X equals 50 will be the maximum. And when one side is 50, and it's 100 take 50, well, that will be 50 also. Anytime we get one of these, we can check them on the calculator. For example, we'll go into graphing mode. 100x take x squared. All right, we can't see anything, which sounds freaky, but that's because we're probably in the wrong mode to see stuff. You can click zoom out for this. Or if you know what the x should go to, so I know x really here should go to at least 50. In fact, it will probably go to 125. And the y value is going to be the area, so this could easily be 10,000. Yeah, there we go. G-solve maximum. Maximum occurs at 50, and the area is 2,500. All right, I guess the 10,000 was off. But what that shows is the maximum is occurring in x equals 50. The way we show it algebraically is the x of the max is minus b on 2a, subbing the value is x equals 50. Question 4. All right, 3 sides of rectangular paddock are to be fenced, 4th from an existing water drain. All right, water drain, paddock. 1,000 meters of fencing available. What area should be used for the paddock? What dimensions for the paddock should be used to maximize its area? All right, well, I'd call that x and y. And then I'd use a similar trick as before. 2x plus y equals 1,000. Y equals 1,000 minus 2x. So that is 1,000 minus 2x. Don't be afraid to introduce 2 letters to start with. Bear in mind you're aiming to replace one with the other as soon as possible. All right, so 1,000 take 2x times 1,000. And then we want to maximize the area. So we have the area is going to equal length times width. Area is x multiplied by 1,000 take 2x. Area is 1,000 x minus 2x squared. All right. The maximum x value is minus b on 2a, which for us is minus 1,000 over 4. 1,000 over negative 4 rather is positive 250. So what that is saying is that we want a 250 here, a 250 there, 1,000 minus 2 lots of 250 is going to be a 500 here. They are our solutions. 250 by 500 will maximize the area of the paddock. All right, question 5. Got a few to go. 1800 meters of fencing is available to fence 6 identical pens as shown. Explain why 9x plus 8y equals 1800. Alright, let's count the x's. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 x's. 1, 2, 3, 4, 5, 6, 7, 8 plus 8y equals 1800 meters of fencing. Yeah, I'm not actually sure what they're expecting you to write there, because if you look at it, it's pretty comfy that you're looking at 9 lots of one line and 8 lots of the other line. Cool. The area of each pen is given by. Alright, first thing we should notice, even though I didn't notice it straight away, is that there's no y in this equation. So you're all thinking, well, great, and so was I. Area is x, y, sorted. But there's no y in there. So what we're going to do is rearrange this until we get y on its own. So 8y is equal to 1800 minus 9y, 9x. Then we're going to divide both sides by 8. Y is 1800 on 8 minus 9 on 8x. You could do it all as over one big fraction, but I strongly suspect that 1800 on 8 is actually going to be equal to 225. Y is 225 minus 9 on 8x. Alright, 225 minus 9 on 8x. Cool, easy. That's the y value, and we know that the area of each pen is xy, therefore the area is given by x bracket 225 minus 9 on 8x. Area is 225x minus 9 on 8x squared. Cool. If the area enclosed is to be maximized, what are the dimensions of each pen? Alright, we could do the minus b on 2a, but to mix up a bit, let's graph it. 225x minus bracket 9 divided by 8 bracket x squared. Ooh, the pen is bigger. So you can move around like that. G-solve maximum when x is 100. What are the dimensions of the pen? Alright, well, if you know x is 100, you then need to find y. So you would sub 100 in there, and that would give you a y value. Which I actually don't really want to do, but okay, whatever. 225 minus 9 on 8 times 100. 9 over 8, 9 over 8, times 100. 112.5. Cool. Easy. Alright, 2h. 500 meters is available to make 4 rectangular pens of identical shape. Find the dimensions that maximize the area of each pen if the plan is A or B. Now, quite nicely, what they've done is they've set up the process of how to do this in 5, and then asked you to do it here separately. Alright, so what we're going to do is follow the exact process through. I'll just do it with A, and you guys can do it with B, no worries. X, Y. Alright, the 500 is equal to 1, 2, 3, 4, 5, 6x plus 6y. I'm hopeful that you guys can probably see that there are 6 of each of those lines that I've defined. We know we need to rearrange one of these. We'll rearrange to get y by itself. So y is 500 on 6 take x. If you go through the rearrangement steps, you'll end up there. Area of each little pen is xy. Area of each little pen is x bracket 500 on 6x minus, don't expand in just yet, minus x, which then goes to 500x on 6 minus x squared. And we're looking for the value of x which maximizes that. So we can go to our graph function, delete whatever we had before, bracket 500 on 6 bracket x minus x squared. Math error, because I hit a space bar above. Oh, sorry guys, you get to watch me type stuff into a calculator. 500 on 6 bracket star x minus x squared. If you have no idea what's happening, just one option is always to hit, well, after you draw, hit zoom auto, and it gives you some idea of where we're going. View window, right, x needs to go to at least like 60, and y can probably go a little higher and higher to 1500. Nearly got it. Resolve max. So our x value is 41 2/3. And then we would sub that into there to find the y value. All good. Alrighty, question 7. The graphs x squared minus 3x and 2x take x squared are illustrated. Show that the graphs meet where x equals 0 and x equals 2.5. Alright, so we've done where graphs meet before. You set the equations equal to each other. X squared minus 3x equals 2x minus x squared. Alright, add x squared to both sides, 2x squared, and let's take 2x from both sides, minus 5x equals 0. So just move the right hand side over. Then let's factorize. X bracket 2x take 5 equals 0. Therefore our solutions are x equals 0 and x equals 5 on 2 as shown. And the maximum vertical separation for the curves between 0 and 5 on 2. Oh yeah, that's 5 on 2. Alright, so we're really thinking the maximum vertical separation is probably happening somewhere there. And to find the separation, so the vertical separation, or VS, is going to be top minus bottom. Alright, so the top one is the purple one. 2x take x squared minus the bottom one, which is the green one. X squared take 3x. Alright, now we're going to find, well, vertically separate that. That negative effectively hits both of them. So we're going to have a minus 2x squared on the end here. That negative makes it a plus, so it becomes 5x minus 2x squared. And we need to find where that maximizes. Instead, what I'm thinking I might do is I might put all 3 of those into the calculator to show you. X squared minus 3x, 2x minus x squared, and then finally 5x minus 2x all squared. Draw. Oh, shift, view window, standard. Standard, forget it. Initial. Alright. If you've got something like this, you can mix up the style of them. For example, here I can go style dotted. The dotted is the resultant one. So, note, for the dotted line, when it hits 0, there and there, is when they meet. You see the meeting down there when it hits 0. When it maximizes, that's the total gap between. So we can go to solve maximum for the y3, and it gives us that value there. Same with minus b on 2a, but that value is about the 1.25 that we're looking at here, and that will give us the maximum value. So when x is equal to 1.25. Alright, question 8. This is the last one. Good work, guys. Infinitely many rectangles may be inscribed within the right angle triangle shown alongside. One of them is illustrated. This is very much a stage 2 exam question style. Alright, let x BAB. So anytime they give you information, write it into the diagram. X. Let BC be Y. Y. Use similar triangles to find Y in terms of X. Okay. Okay. Y in terms of X. All right, let's take the two triangles. There's a third bigger triangle as well, but okay, let's just point out for a start, there are three similar triangles here. There's this one, there's this one, and there's this one. And I'm hopeful you're all happy to see that using shared angle. They've all got a right angle in the bottom left. If you're thinking about these ones here being parallel because it's a square, so you know that that's a right angle as well. And then you are thinking, well, that angle here and this one here is corresponding, and you can prove them all similar using angle, angle, angle. So yeah, the stuff you guys did in year 10 and earlier is still applicable here. All right, three corresponding sides. Three corresponding similar triangles. What that means is that the ratio of their sides is all equal. So, bottom on top. That divided by that will be equal to the same pair of sides. So we have X here and Y here. I'm going to call this one here 6 take Y. So, top divided by bottom. It actually doesn't matter which way around you've done this. X on 6 take Y equals, this would then be 8 take X. 8 take X on Y. Now, any three of these will come up with essentially the same argument. We can take any pair of these equations. I'm just going to take the first pair and essentially cross multiply. So 8 bracket 6 take Y equals 6x. 6 8s are 48 minus 8y equals 6x. 48 equals 6x plus 8y. Is that what it asked me to do? Find y in terms of x. Right, I need to get y by itself. So what I just did then wasn't hugely useful. 48 take 6x divided by 8 equals y. Cool. Find the dimensions of the rectangle ABCD of a maximum area. Alright, we've already done the first step. We found x in terms of y. So instead of the area being xy, the area is now x bracket 48 takes 6x on 8. Area equals, well, you can expand that out, 48x minus 6x squared on 8. And then we can maximize that either algebraically or using our calculator. Big fan of the calculator. Sorry guys, you've got to watch me delete all these. Try the calculator here so I can actually see it. We're going to go with 48x minus 6x squared divided by 8. Alright, we need to fix our view window again. It's going to probably go out to like 20. And the maximum, probably 100 or so. 100 was way too big, but the point is we can see it. G-solve, max. X is 4. So the maximum area occurs when x equals 4. And we can sub that back in to find the value for y. Actually, oh yeah, it's a rectangle. Might be a square, but we'll see what the value for y is after we sub it in. Alright, thank you very much. Hopefully you haven't watched this whole thing, you've just jumped between the questions you wanted. Cheers, bye.